Hello, my fellow YouTubers. Woo! NASCAR. Let me step back right now. See what you're looking at. This is what I'm looking at. I'm Roy. Freezing my ass off down in North Florida, USA. 42 degrees. I certainly could be complaining, but the country's cold if it's cold here. A couple things I want to talk to you about. You'll be interested in if you're curious how this wheel could turn without using the outside PMHs. I think I got a theory I like to go over with you guys. It's sort of like the Searle machine. And I want to thank you out there leaving your comments, because I didn't really know much about Searle, and I got to believe that he got half of the information, and the half is what I noticed, and that's what I'm going to move ahead and move on over to Ed Leedskalnin. Now, what I kind of ran into was a roadblock. The roadblock was the PMH. Let me grab one of these guys. In my mind, it's going to be the outside driving force on pulling and pushing the wheel. 2 to 4 of these. Now, I started off thinking I'd make 2 for pushing power, put coils on the back for pickups, stealing some electric back on the back EMF, and then on the second one that I would be doing the same thing to take half the load off of turning the wheel and pull from that. But I also have in mind 2 other PMHs that I'll have to try experiments. They're either going to be part of the process to where they all share the pulling and pushing, and that brings more efficiency to the system. And if it does, it does. And bam, we learned it. But I'll have to try it first. Secondly, if I ran into this roadblock and I said to myself, somebody sent a comment in on Searle machine. So I did the research, and basically a little bit about me. I was turned on to Wilhelm Reich. Somebody handed me a book when I was 17 years old. I was over 36 years ago. So I started reading about Wilhelm Reich, and he was into orgone energy, organic, inorganic materials, repelling and retracting. He said that organic materials attracted, and he said that inorganic, your metals, they absorbed, but they also retracted. So they had 2 powers to them. So looking at the Searle layout, I realized that what he's creating is a magnetic flux around the outside of his wheel, but he's doing it in layers. I'll go over with the layers with you right now. And here's a cow magnet. This is pulled north and south, top and bottom. Okay. This is another type of field magnet that has individual parts to it and metal spacers, and it's probably 100 times stronger than this one. But I think that one can be recharged to be stronger. I can maybe use the PMH to recharge it. It says north and south is on either end. And maybe I won't charge it in the beginning because it's not as strong as that one is. You can see it falling off, but you put it on the side. Look, it ran from that. See, I don't know. I guess I got some. It's crazy. This thing is jumping out of my hand. I don't know what's going on here. This is kind of new to me, but it's got the roll effect about it. There it is, sticking finally, but it's like when it gets in motion, it just runs. But anyway, enough about this one. See if it sticks over there. This bitch is strong pulls. I can't barely get this off. I'm struggling right now pulling it off. This one pulls off, but with the Searle motor, if I incorporate that to Leedskalnin, what got me interested was, what if this V-shaped magnet right here, and they're all linked together, okay? Now, what if this V-shaped magnet was to, because the attributes that I seen about it, using them for years on Ed's PMH, and then making them myself, I made these, and they're soft iron, and these are from Ford Motor Company that are charged. From when I made those, I realized that these magnets here were able to be charged over and over like a car battery, but they were also able to swap poles. And like the way I have them here, before I realized what I was doing with wrapping the wheel, I wrapped the wheel once. Then I took it apart. I didn't like what I seen. And what I didn't see was everyone was linked together. So when you start doing south, north, south, north, south, north, it became where I guess I got confused because of the way my brain works. Little ADD out the wazoo. So I think I probably got confused or crossed over on some of the turns. And then I was heating them up because I was just running them straight into the power source. So they were overheating real quick. So I realized that I need to take them apart the way my brain works, and I need to do one at a time. So what I started doing was I took 6. I said, I'm going to start with 6. 6 goes into 24 4 times. So I'm going to do 6. Look at the ohms on each one. It was like 0. I think 92 or 94 or something like that. So each one times 6 gave me enough ohms to run off a 12 or 24 volt charge into the system. So they're set up for that. And then I have them where they're all north and south. Back to Searle. So now I have these magnets that could be juiced up from the coils and become Superman strength. Or I can go down in voltage and have them vary where I want them, or I can not even induce them and maybe use them as a pickup through the Searle machine. This is what I'm thinking. I need to clean out the inside of my wheel. If you look in the inside of Ed's wheel, it's the same, but I was a little sloppy on my cement, so I need to get the cement. And what I want to do is at least have a little exposed of each neutral part of these magnets, okay? I believe Ed's wheel was designed 5 high because of the length of these cow magnets, which what you have here. They fit too perfect. And also, they go together perfect in here. So what I was thinking was, if I use these magnets here as a push and pull, and I create the push and pull on either, on both sides, okay? If I put a ring inside here that's touching all the neutrals, okay? I'll have to do research to see whether it's a magnetic ring or it's a aluminum or copper or that type of conductor, or do I go to metals, look on the chart and see what's more of a positive or negatively driven metal. That means that metal will be the predominant charge, the negative or positive. But what I'm thinking is with the separation metal in here between this magnet and the neutral backside of Ed's wheel, you'll have this thing turn and roll over and over and over, okay? Here's where the front side comes in. If I make the metal the opposite charge, so if I use a metal in here that's inertly, say, a negative charge, then I would want to use a positive charge plate over here. Now I have not only these magnets as I turn this, say with my hand, not only will I have these magnets start to turn along, because they'll be on something, and they'll see what I just showed you, how they rolled. They'll follow a path based on the magnets that are inside here, the rings, the stack 5 pile there will allow this magnet to keep rolling. You know what happens when you take a metal and you put it in between, say, 2 magnets? Okay? This thing don't even want to stick to this magnet anymore because it moved over. So it kind of becomes a shield. So this would turn, if I was turning the wheel this way, these magnets most likely would turn the opposite way. Okay? Then out here I would make a ring, and I'd come off of this pipe here, and I would make the ring come around, all the way around. Alright? All the way around. And I would put these magnets on the outside of the ring. So the plan would be is when you turn, create the centrifugal force. I already know on the outside the magnets are going to want to go this way. If you're turning the wheel this way, the magnets go that way. I already seen it with the metal shavings I put down here with a mirror. You go back to one of my long time years ago video, you'll see the pieces of metal go the opposite way of the turn. So that means the outside magnet would be doing the same thing. That means this magnet outside here on the outside of the ring would start to turn the opposite way. I believe what I'm creating with the Searle machine type of approach with this Eds Wheel is the fact that this magnet in the middle, which is a small voltage, doesn't need a lot of voltage. It's going to, because of the iron, it's going to be chasing this magnet. Because of the turn of this magnet, which is pushing this way, is going to create an inertia that runs it back the opposite way. So it's going to make the wheel want to kind of go this way. Now, what's going on the inside, the magnet is set the opposite, and it's going this way. So it's making this wheel here push this way, and this magnet is turning this way. Where on the outside, the magnet, you're turning the wheel, the magnet is turning the opposite way. That's the road, the stop in the road where I say, okay, before I go any further here, let me go ahead and just swallow this, digest this, and say, okay, where you go from here, because it sounds fascinating. Leave your comments. Guys, real quick, I'm going to go over something. This is part of the design that I have here. It's going to collect 12 volts DC. It's hooked up to my voltmeter. Obviously, you see the voltmeter is on 200. And this is a pulse system that I'm taking 12 volts and charging the capacitor array to hold the charge, and you'll see it show up on the voltmeter. And I want you to see how many times I tap this. I'm going to probably just move this closer so it's in the same frame as me pulsating. Okay, so here's the negative and here's the positive, and here's the voltmeter, and we're going to get to where you can see both. Let me move this apparatus over. This is monumental because I'm going to talk about the charging capacitor system I'm going to build for this wheel, and we're going to talk about energy we can get off of it in different ways. Here you go. I'm going to touch, and every time I touch, you can see, look, there's a climb in voltage. I'm at 26 volts. Okay, I'm at 39 volts. Watch my volt. I'm at 52 volts. Okay, I stopped hitting the son of a bitch. I'm at 47, losing some. I got to put a diode on it, but check out. Like, I keep touching it, and the voltage is up to 63. Let's get it up there. I'm going to show you. I'm at 75, 76. I don't want to do 100, but I'm going to do 85, 80.